quadratic equations, functions, zeros, and models, we're going to first talk about the quadratic formula. This is a different way in which we can solve quadratic equations. And what's wonderful about the quadratic formula is that it works every single time. There aren't any parameters for when it may or may not work. It will always work. The formula is based on ax squared plus bx plus c. So we're going to pull the coefficients a, b, and c and use the formula to plug in them. We have to make sure that we have an a value. It can be 1, it can be a fraction or a negative number, but it can't be 0 because notice in the equation, the formula itself, we have to take 2 times a in the denominator. And if we have a 0 there, well, we can't do it. So let's solve 3x squared plus 2x equal to 7. Find the exact solutions and approximate solutions rounded to 3 decimal places. So first of all, notice that in our formula we have it set equal to 0, so we need to also do that here as well. So we want to make sure that our equation is set equal to 0 first. To do that, I'll subtract 7 from both sides. Now I can pull my coefficients. A is 3, B is 2, and C is negative 7. At this point, we'll plug in to our quadratic formula. So x equals opposite of b, the opposite of 2 is negative 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a, which is 3, times c, which is negative 7, all over 2 times a being 3. We can now use the order of operations to simplify. Negative 2 plus or minus the square root of 4 plus 84, which is negative 4 times 3 times negative 7. Well, 4 plus 84 is 88, and we're going to continue to solve here. I'm going to break apart 88 into 4 times 22 because I can take the square root of 4. Well, when I take the square root of 4, we have 2. Now I'll have negative 2 plus or minus 2 square root 22 all over 6. I notice that 2 and 2 are both divisible by 2, so I can factor out or divide them by 2. And in my denominator, I have 6. I can take 6 and split that into 2 times 3 again, and I have a common factor in my numerator and in my denominator, which reduces to negative 1 plus or minus the square root of 22 over 3. Now our exact solutions are negative 1 minus square root 22 over 3 and negative 1 plus square root 22 over 3. These are the exact solutions, and our approximate solutions plugging into a calculator would provide us with negative 1.897 and 1 and 23/100. Let's try another one. Here we have x squared plus 5x plus 8 equals 0. Our a value is 1, our b value is 5, and our c value is 8. Plugging into our formula, x is equal to the opposite of b, so opposite of 5, negative 5, plus or minus b squared, which is 5 squared, minus 4 times our a value of 1 times our c value of 8. This then provides us with negative 5 plus or minus the square root of 25 minus 32 all over 2. And when I take 25 and subtract 32, we have negative 7. Let's think back to our negative values. I have negative 5 plus or minus the square root of 7 times the square root of negative 1. We know that the square root of negative 1 provides us with the value of I. So we have negative 5 plus square root 7 over 2 and negative 5 minus square root 2 over 2 with the I values attached to both of those options. We also have what we call the discriminant. The discriminant will tell us what type of solutions we may have. If we solve for the part that's underneath the square root, so the b squared minus 4ac portion, that's the discriminant itself. If it is equal to 0, we will have one real number solution. If it is greater than 0, we will have two different real number solutions. And if it's less than 0, we'll have two imaginary number solutions, of which those are complex conjugates. Let's solve for x to the fourth minus 5x squared plus 4 equal to 0. Notice we don't have an x squared here, so we need to make an x squared. So I'm going to let u be my x squared value. Then, if I square both sides, u squared would then equal x to the fourth. So I'm going to replace x to the fourth with u squared, and I'm going to replace my x squared with u, providing us with u squared minus 5u plus 4. At this point, let's see if we can factor, because it is much more quick than using the quadratic formula. So what multiplies to 4 and adds to negative 5? Let's see here, negative 4 times the negative 1. A negative times a negative is a positive. And negative 4 plus negative 1 is negative 5. So we found our solution. We will have u minus 1 and u minus 4. We know that once it's factored, we can set each factored piece equal to 0. U minus 1 is 0, or u minus 4 is 0. But we didn't actually solve for x. We solved for u. So at this point, we want to take our u value and re-give it back, replace our u with our x squared. So x squared is equal to 1, and x squared is equal to 4. Now we can finish solving for x squared by taking the square root of both sides. Taking the square root of 1 will give us plus or minus 1, and taking the square root of 4 will give us plus or minus 2. So our solutions are negative 1, 1, negative 2, and 2. Example 4. Notice we have fractions as part of our exponents. So I'm going to let u equal t to the 1/3 power, and notice that that's our middle term that we're using. That was the same with this other example. I let u equal the middle term. Therefore, what if I square both sides? Take u squared and t to the 1/3 squared. We know that a power to a power we multiply. 1/3 times 2 is 2/3. So when I see u squared, that's the same as t to the 2/3. And notice t to the 2/3 is our first term. We know then that we'll have 1/3 t to the 1/3 squared minus 2t to the 1/3 minus 3, kind of going over that piece one more time. That will give us then u squared minus 2u minus 3. We want to factor, so we'll multiply to negative 3 and add to negative 2. Looks like negative 3 and negative 1 will work. This gives us then u minus 1 times u minus 3. Once it's factored, we can set each factored piece equal to 0. U plus 1 is 0, or u minus 3 is 0, giving us the results of u equals negative 1 and u equals 3. But we didn't solve for u. We need to solve for t. Remember that u is the same thing as t to the 1/3. So t to the 1/3 is negative 1, and t to the 1/3 is 3, replacing back the original variable. How do I undo a 1/3 power? What we can do to make it into the power of 1 is multiply by 3. since 1/3 times 3 is 3/3, or back to 1. When I multiply the left and the right to the third power, I'll have t equal to -1. And when I do the same to t to the 1/3 is equal to 3, when I cube both sides, I have t equal to 27. So our solutions are -1 and 27. The number of museums in China increased from approximately 2,000 in the year 2000 to over 3,500 by the end of 2012. And in 2012, a record 451 new museums opened. For comparison, the United States, only 20 to 40 new museums were opened per year from 2000 to 2008. The function h of x can be used to estimate the number of museums in China X amount of years after 2005. Let's estimate the number of museums that will be in China in 2017 if the number of new museums opened that year continues at the same rate. So h of x represents the number of museums, and x represents the number of years after 2005. So if I'm looking for the number of museums that opened in 2017, that would mean that x would be 12 since 2017 is 12 years after 2005. So we will want to evaluate our function at h of x at 12. So h of 12 is equal to 30.992 times 12 squared plus 4.108 times 12 plus 2,294.594. Plug and chug it into our calculator, we obtain that approximately 6,807 museums will be in China. What if we wanted to determine in what year the number of museums in China was 2,600? Well, this represents the number of museums was 2,600. That represents our h of x value. If 2,600 represents our h of x value, then we need to solve for x. So to do that, we can use the quadratic formula. But first, we need to set this equal to 0. So I'm going to subtract 2,600. When I subtract 2,600, I have 0 equal to 30.992x squared plus 4.108x minus 305.406. I now can identify my A, my B, and our C so that we can plug them into our formula here. The opposite of B would give us negative 4.108 plus or minus the square root of B squared minus 4 times our A value times our C value all over 2 times our A value again. Definitely use your graphic calculators here. These are some pretty crazy numbers that we need a little bit of help with. When we add, subtract, take the square root, and then divide finally, we have two choices. We have about negative 3.206 and 3.074. When I think about x being the number of years after 2015, we can't look, 2005. After the year 2005, we can't look at negative numbers because we can't have negative years. So this negative result doesn't make sense. The only result would be 3.074. So about 3 years after 2005, there were 2,600 museums. So we could say in the year about 2008 sometime that this happened. The number of both magazine launches and magazine closures have increased in recent years. The function m of x equals 34x squared minus 59x plus 81 can be used to estimate the number of magazine closures after 2012. In what year was the number of magazine closures 99? So when I look at m of x, that represents magazine closures. Where my x value represents the years after 2012. So when I look at the value of closures of 99, that means I'm going to replace our m of x value with 99 and solve for what year that will happen. When I plug in 99, I need to subtract 99 from both sides so that I can obtain 0 equal to 34x squared minus 59x minus 18. Using the quadratic formula, my a is 34, my b is negative 59, and my c is negative 18. Plugging into our quadratic formula, x is equal to the opposite of b, so the opposite negative of b, which is negative 59, plus or minus the square root of b squared minus 4 times our a value times our c value all over 2 times our a value. This gives us 59 plus or minus the square root of 5,929 over 68, which gives us two results. 59 plus 77 over 68, which is approximately 2, or 59 minus 77, which is over 68, which is approximately negative 3/10. Since x represents the number of years after 2012, the negative answer doesn't make sense in the context of this situation. So 2 would be the approximate years after 2012 where there were 99 magazine closures. So 2 years after 2012 would provide us with 2014. And this concludes our lesson on quadratic equations, functions, zeros, and their models.